This is Mrs. Hedden. I'm helping you with the Graphing Practice Linearizing Data Worksheet, and I'm doing the first one in case you needed help. First thing to do is to graph the original data in graphical analysis. Be sure to include titles and units. So I'm going to the X, double-clicking, and I'm going to put in the mass, short name, and units. Then I'm going to go over to the Y column and double-click on it and put in acceleration, short name, and the units per second squared. Now I'm going to enter the data. I've got the data in, and while I can see the points and I can probably tell what the trend is, I would like to see the line too. So I'm going to right click on here, go to Graph Options, and go over to the Graph Options thing and say connect the points for me, please. And now I can definitely look at that and tell that's an inverse relationship. Looking on that summary sheet I gave you guys on Friday, an inverse relationship means we're going to graph y versus 1 over x. So I'm going to get a new calculated column and have the computer calculate 1 over x. Go to Data, New Calculated Column. I'm going to call it 1 over mass, because that's my x. Short name, 1 over m. Units, 1 over kilograms. And I'm done. Oops. I'm almost done. I forgot I've got to put the expression in. The equation is 1 divided by the mass, but remember I have to pick the variable. So I pick mass. Now I'm done. And it's calculated it for me, but I don't see any difference in the graph because I have to tell it to graph it. In this case, the y value is staying the same and the x value is changing. So again, I right-click anywhere on the graph, go to Graph Options, go over to the Axes options. Y-axis is fine in this case, but I do have to change the x-axis. So the x-axis is going to be 1 over mass. Click on that, hit Done, and now I can see I have a straight line. So, remembering that I had to sketch what the original data looked like on the worksheet, so I had to sketch that inverse relationship. I already took the clues from the shape of the first graph. I modified the data. Now I need to write the formula of this line. To write the formula, I need to have the slope quantity. So I do a linear fit, and now I'm just going to write the data here on this screen so I can show it to you. Okay, the general form is y equals mx plus b, but we want a specific form. That means that we're going to go in here and we're going to look at the slope, and we're going to use this value for slope, and we're going to look for the y-intercept, and we're going to use this value for the y-intercept. So instead of y, we want to put what's on the y-axis, which in this case is acceleration. So I'm going to use the letter A, equals. Instead of m, I want the actual value for slope. I've got 8. I only have 2 significant digits in my data from the original data, so I'm going to go with 8.1 meters per second squared times x, but instead of writing x, I want to write what's actually on the x-axis, which is 1 over mass. So I'm going to do 1 over m plus b. b is 0.01. It's negative 0.01, but again, I only have 2 significant digits. This placeholder is really insignificant. I suppose I could say it's negative 1.5 times 10 to the negative 2, but that doesn't really make a lot of sense. It's really just rounds to 0. So I'm going to rewrite this a little bit neater. I have A equals 8.1 meters per second squared times 1 over m. And that would be the formula for that particular line. When you print this out, make sure the linear fit box is open and showing on the graph. Make sure your name appears somewhere on the graph. It's handy. You can go up to the computer when you go to print. You can have your name appear here on the footer. So I'm going to put down Mrs. Hedden. Okay, and you can print it that way. Or if you wanted to, you could make this box smaller and put it in the notes. Thank you very much for your time.